All right, chillins, today we are going to be looking at slope, and specifically slope as a rate of change. Now, most of you are familiar with the term slope already, so we're going to be talking about slope and how it applies to a rate of change and some basic ideas with it. So let's consider the problem that we have first, and then as we walk through it and as we talk about it, we'll go ahead and put the idea of slope in. All right, so here we go. We've got Ryan walking away from a motion detector, which we did in class, at 2 feet per second. Now, remember when you walked away from the motion detector, what happened to the line? Hopefully you remember that it was going up because it was showing that your distance was increasing, right? So here's some more information. You missed where he started, but you know that he was at the 11-foot mark when the timer called out the 4-second. So after 4 seconds, he was at 11 feet. So let's go ahead and first decide what's independent, what's dependent, and hopefully you recognize that distance depends on time, right? And you know that just because you know that time goes on the x-axis, and you know that distance, and I'm going to label this as distance from the CBL. CBL is another fancy name acronym for the detector. So this is the distance from the detector, right? Which is important that we don't just say distance, because it's not the total distance he's walked, it's just the distance from the motion detector. All right, so let's go ahead, and at time 1, 2, 3, 4, he was at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So at 4, he's at 11. Okay, now let's see if we can kind of build this. He's walking away from the motion detector at 2 feet per second. So at 3 seconds, where would he have been? Remember, he's going 2 feet every second. So if he's at 11 after 4 seconds, 2 feet before that would be 9. So 3, 9. Okay, what about 2 seconds? Where would he have been? 2 feet before that, which would be 7. So we can go to 2, 7. All right, at 1 second, 5 feet, and then of course at 0 seconds, 2 more feet back would have been at 3. Now this helps us with a couple of things. Number one, we can see that this is a linear equation. Now of course the linear equation comes from similarly the idea we talked about tables before, right? If I do the differences here, what do I get? Well, 11 minus 9 is 2, 9 minus 7 is 2, 7 minus 5 is 2, 5 minus 3 is 2. We note that there is a first common difference. So yes, it should make sense that I'm getting a linear graph. Wonderful. Well, let's now throw in the idea of slope, of rate of change. Now, when we look at the growth rate, the rate of change, which is the slope, what we can do is we're looking at how y is changing as x changes. Y depends on x, but in what way does it depend on x? As x changes, what's happening to y? And we can see that every time x increases by 1, y is increasing by 2, right? You can see that in the table, you can see that in the graph. Every time x increases by 1, y increases by 2. So the way that we say the rate of change is we say that y changes by 2 feet per 1 second. Now you can reduce that if you want, and you could say 2 feet per second, but it's okay to write it as a fraction, a ratio like this. But anytime we show a rate of change, we're going to show it as a ratio, right? Rate and ratio kind of go together, and we want to show it as a ratio, which is division, to be able to show the idea of how these two things are being compared. Now, how far away from the CBR did Ryan start? Well, at the start, that would be 0 seconds. He was 1, 2, 3 away. And this point is called what? The Y-intercept. All right, well, I want to show you one other thing, actually 2 other things. Mathematically, we can always find the slope by using an equation. The equation that we use is m equals y2 minus y1 over x2 minus x1. Now please note that these are not exponents. They're not up at the top. They're not a superscript. They're actually a subscript. In math, anytime you see a subscript like a 1 or a 2 down below the y, that's actually talking about a point. And so what we need to do is we need to choose a point 2 and a point 1. You can choose any point on the line. You can choose anything in between if you want. But it will be a lot nicer and easier to use if we just choose a couple of points that are on the line. So I'm going to take this point 4, 11. I'm going to take this point 2, 7, and those are going to be my 2 points. Now I'm going to call this one my first point and this one my second point, because now I'm just going to go, it doesn't matter which you designate as which, it's going to work out no matter what. So let's go ahead and put the numbers in. Y2 is the y value from the second point, so that would be 11. I designated that as my second point, minus y1, which is the y value from the first point, so that would be 4, over, or sorry, that would not be 4, that would be 7. I'm glad one of us is thinking. All right, so x2 is the x value from the second point, which is 4, minus, and then x1, which is the x value, which is 2. Now, if I were being a good Algebra 1 student, I really should put these in parentheses. Since they're positive, it's not going to make a difference. But just to keep in mind, that's probably what we want to do. 11 minus 7 is 4. 4 minus 2 is 2. And if I reduce that, I get 2 over 1. So note that that 2 over 1, that slope, is the same as this right here. Now, slope can also be described as rise over run. Please note that the y's are the up and down, so that's the rise. The x's are the run, so that's my side to side. And so when I add in rise over run, I'm going to rise 2, run 1. Rise 2, run 1. Rise 2, run 1. And so no matter where you start, even if you start in the middle here, rise 2, run 1. And so the slope will always be 2 over 1, which is this y2 over y2 minus y1 over x2 minus x1. It is also this rise over 1. So I hope that's helpful as an introduction to slope. If you want a little bit more, another practice problem, look at another idea, please go on to the next video. Even if you don't want to, go on to the next video anyway, because it's your homework. Ciao.